So I always like to start with the exponent laws and then we'll go from there. So a to the m times a to the n. What do I do with the exponents? What do I do?
Exponents.
Sorry?
Add exponents.
Add exponents. That's right. So I got that. A to the m over a to the n is subtract the exponents. A to the m to the n is multiply the exponents. So far we're okay, right? How do I make this? I don't know if I need this, but how do I make that a positive exponent? Put 1 over it, that's right. So that changes it to that. A to the 0, of course, is equal to 1. Okay, so that's all our exponent laws. Well, we're going to do the same thing with logarithmic laws. We've done it already, we're going to do it again. So, much similar to trig identities, the point of the logarithmic laws are to make the question easier or more manageable, or it's, to be able to do it. So I'm going to give you the two types of questions that occur on the exam and how you have to, one of them you solve by changing to logarithm, and then one you solve by changing logarithm to exponential in order to solve them. Okay? That's what we're going to end up doing. So an example of that would be this. If I had log of, I don't know, this is all hypothetical, plus the log of 3 is equal to 6, let's say. All right? Something along this lines here. Okay? So when I have the two logs, I want to put them as a single logarithm. So if you recall, the law of logs was when you added them, you could put them together and be one and multiply them. So it would look like this. It would say log 3x. So I put it in brackets is equal to 6. And then once I have it here, I would change it to exponential. So I'd have 3x is equal to 10 to the 6. And then I would divide by 3 to solve the question. I would get x equals 10 to the 6 over 3. So 9 over 3, whatever. But this is all I'm doing, so I just want to demonstrate. This is one of the questions that we have to be able to do. We have to change from multiple logarithms to a single logarithm so that we can convert it to exponential. But in order to do that, we have to remember our logarithmic laws. So log of m plus log of n is the same as the log of m times n. Okay, so far? Log of m minus the log of n is the same as the log of we divide it, right? All right, so this one is new to us, okay? So we've done this, but it still is, it's kind of like the power to the power one. So what do I do? Take that exponent and I move it to the front. So I get n log m. Now I'm doing this in one direction. You need to be able to do it working backwards as well. Identify it. So all of 8.3 is just fiddling with this as well. Okay, and then the last two that we do, the log of m to the base m is equal to what?
1.
Just 1. The log of any number to the same base is equal to 1. Okay? Alright, I can show you why, or you can just believe me and remember that. Okay, it's easier to do it that way. Alright? Okay, so that's what I have there. Okay? Did I take care of all of them? I believe so. Yeah. So 8.3, all it is expanding logs and making logs smaller. So we have done a lot of that already. So if you do 5 or 6 of them and you remember how to do this, scrap it and go on to the next. Okay, we got to get through these things quicker than normal. So let's try one here. I've got the log of x squared y over base 4 over 4z.
I think it's x cubed. X cubed y.
Is it x cubed? Mm-hmm. Thanks. That?
Yep.
Okay. So what I'm going to do, I have all of this here. I don't know if they put brackets on it or not. I always put those in brackets. I would suggest you always put those in brackets. If you use the log button on your calculator, it always opens up brackets. I always put it in there. How many terms are inside that bracket? How many separate terms are there in that bracket? 4. X cubed, y, 4, z. Okay? So I'm basically saying there's 4. It looks like, yeah, maybe I didn't express that the right way. You probably write 2 terms, top and bottom, but there's 4 different scenarios that are happening here that we need to break up is what I'm getting at. Okay, so to do that, if it's multiply, it means add. If it's divide, it means subtract. So I'm going to tear this apart. So it's going to be this, log x cubed to the base 4 plus log y to the base 4 minus log 4 to the base 4 minus the log of z to the base 4. We okay?
So you just minus the bottom?
Yes.
Okay.
Yes, to me this is the easiest way to do it. If it's on the bottom, make sure there's a subtract in front of it. The book will maybe go subtract all of that with an add in the brackets, and then you have to distribute it through. It's easier if I distribute right now. Questions about it? Yeah.
I just don't get like the adding and subtraction.
Okay. So let's go back to this, Georg.
Yeah,
The log of m times n
yeah,
is the log of m plus the log of n.
yeah.
Yeah?
Yeah.
Okay, so now let's look at this.
Yeah.
I've got the log of x squared to x cubed times y.
Mhm.
The log of x cubed plus the log of y.
Yeah.
The log of m over n means I take the log of whatever's on top and I subtract the log of whatever's on the bottom.
Okay, yeah, that makes sense.
So now I subtract that and subtract that on the bottom.
Yeah. Okay.
You okay?
Yeah, that makes sense. Thanks.
Yep, yeah, perfect. You good now? Down, but you're good? Okay, I'm not sure what he did there. Okay, so now I want to simplify it. What can I simplify in this? What can I simplify here?
Four.
No, right here. This guy. What can I do?
3 logs, 4x.
Say again?
3 logs, 4x.
Yeah. Move the 3 to the front. Anything here? Oh. What is that?
1.
There's my final answer when I expand it out. Okay? Now, if there was things that were alike, I could maybe add and subtract them together, but they're not. They're all completely different. So I can't do that. Questions? We remember this? A little bit? Who doesn't recall this at all? Be honest. You just don't recall this at all? Didn't even apply it?
That makes sense.
Okay. Lauren, you okay though?
Yep.
Okay. Alright, I'll do one more with you, and then I'll go the other way. So I have a log of, I'll do this one here. I like this one. Log of base 5 square root x y to the third. Okay. So far so good? All right. There are a couple of ways I can do this. It doesn't matter how. I can change the square root to an exponent right now if I want. Okay, that's one way to do it. I can leave it, separate it, leaving the square roots on those values, and then changing it to an exponent, whatever you want to do. What is the square root to an exponent? As an exponent, sorry. A half. Okay? So that's a half. So what I could do then is this. Let's go log of xy cubed to the 1/2, like that, base 5. That's a possibility. If you want to do it that way, that's fine. Okay? So now what I would do is I'd get the log of x to the 1/2 to the base 5, add log of y cubed to the 1/2 to the base 5. Okay? Okay? Any concerns? All right. One more step in the whole thing here. What do I do with this?
You do it now.
Take it to the front. 1/2 log x base 5 plus, what is it? 3 over 2 log y base 5, and I'm done. Okay?
Do you use a decimal or
No,
don't use decimal?
nix it.
Okay.
Okay? We okay? So far so good? We don't spend a lot of time expanding them. There are some questions but not many. The more important task at hand is what we're going to do next, and that's looking at 276. Let's put these together. So let's make this one single logarithm. Okay? So I've got log x cubed base 2 minus 4 log x base 2 minus log square root x base 2. Okay? How are we doing? You falling? Falling asleep? Probably a little column A, little column B. Okay? Here is how I suggest you do this. Draw a line. Base stays the same. Base 2 for all of them, right? The ones that are positive go on top. The ones that are negative go on the bottom. Okay? I also want to do this. Let's put brackets here. Always put brackets for every one of them. You'll see why when I get to C. Okay, so what goes on top?
X cubed.
X cubed. What goes on the bottom?
X to the power 4 negative x 1/2.
Awesome. Good work. Just like that. Okay? I guess I'm going to leave it just like that. No. No, they did reduce it. Okay, because they're all x's, now I want to fiddle with the exponents here. So I got log base 2 bracket. Okay. X to the third. On the bottom here I have 4.5. What's 3 subtract 4.5? What is it? 3 subtract 4.5 is negative 1.5 or a negative 3 over 2, but if I put it on the bottom it stays as a positive. So there's your final answer right there. Okay? So 3 subtract 4 subtract 1/2 gives me 3 over 2, negative 3 over 2, which I moved to the bottom. You following? Any concerns?
Is negative 3 over 2 log x to the base 2 still considered right?
That?
Yeah.
Yeah. It's still a single logarithm. That's my intended goal. So yeah, I would mark that correct. Okay. Let's look at C. I'm going to jump right to the solution for C. What do I do when they add? Multiply. So it's x minus 3 times x plus 4? You guys got to be a little bit louder. Can't hear you for the fan on top of me here. And my lack of hearing. Okay, so I can leave it at that. I can also change it to x squared plus x minus 12 as well. You can do that as well. Okay? Any questions? Alright. You sure we're okay? Let's look at that first evaluation one. So again, this course, what they're doing with this course is they're trying to get you to do as much as you can without calculators. So look at log 8 to the base 4 plus log 32 to the base 4. Okay. So in order to evaluate these, you're looking to get the numerical value, the 8 and the 32, such that we can eventually cancel it out with base 4. So what does it have to be then? It'd have to be to 4 to the power of something, right? So looking at this right now, if I break these both down to the smallest possible, okay? This could break down to 2 cubed, agreed? 8's 2 cubed. What is 32?
5. 2, 5.
2 to the 5. Now because I'm adding, that's multiply, correct? So far so good? Okay, so that's the log of 2 to the 8 to the base 4. Now that still doesn't help me. It still doesn't help me. Why does it not help me? Because I can move the 8 there, but I still don't know what the log of 2 to the base 4 is. So I need to somehow change this. Instead of from 2 to the 8, I need to change it to 4 to the power of something. Okay? So that's a little more work. So let's think this through and let's think of how I can do that. How can I change 2 to the 8th to 4 to the power of something?
Just a quicker way was you could just put it into a whole number, like find 2 to the power of 8, and then just figure out what 4.
Yeah, I'm trying to do this without a calculator. You have no calculator for this.
You could
Right?
make it like
Is that 4 is not 7?
Okay? I'm going to show you 2 ways. I could have approached this differently to make it easier. I've made it a little bit harder on myself. But here's the question I have to you. 4 to the power of what equals 2?
1/2.
4 to the half? So what if I change that 2 to 4 to the power of 1/2? Would that be the same thing? Yeah? So let's do that. Let's change that to 4 to the 1/2. X to the power 8. Is that still 2? Yeah. Now what do I do with that exponent?
4.
Multiply them. What's a half times 8? 4. And if I move that to the front, what do I get? What's the log of 4 to the base 4? 1. What's the answer to this question? 4. Okay? So far so good? The next way might be a little more complicated. Or maybe not. Actually, you know what? I'm going to show you something different. I'll show you an easier way to do this yet. Okay? So, remember the 2 cubed 2 to the 5th, right? Well, what if I expanded those out? What if I did this? 6, 7, 8. What if I did that? Okay? Then I just focused on all my 4s. There's 1 4. 2 4s. 3 4s. 4 4s. And then rewrite it as 4 to the 4th. Base 4. Does that work too? I'm trying to figure ways out I could do this without my calculator. That's basically what I'm doing. Okay? Now with a calculator, I go 32 times 8 and I find out 4 to the power of what gives me that number. With a calculator. But I don't have that. Okay. Are we okay so far? I got one more magic one here to show you. This guy. This was an exam question about 10 years ago. It got done just so poorly. Anybody know what the answer to that is?
16. I had to say 16.
You're going to say 16?
Because the answer say 16.
Where's the answer say 16?
At the back.
What are you doing checking the answers already?
I was on it yesterday.
Okay? Then explain it to me. On. And not say it's because it's in the back of the book.
It is.
Why is this 16? Yeah, go ahead.
You can change 16 to the 2 to the power of 4, and then put the 4
What?
in front of the log, and then the 2's cancel out to be 1, and then the 4, it's 2 to the power of 4, so it's 16.
Okay. That's wonderful. It really is. I think it's awesome what she just did. Because I wasn't going to do that.
Oh.
I wasn't going to do that. But that's awesome. Okay? This is why. She's absolutely right. What is 16? 2 to the power of 4, correct? And then what do I do with that 4? Move it to the front. So that gives me 2, 4 log 2 to the base 2. What's the log of 2 to the base 2? 1. What am I left with? 2 to the 4, which is 16. That's phenomenal. Okay? Never done that before. How I do it is I make x equal this, and I don't like it already because I like what you did. Now I'm going to change this. I'm going to change this from an exponential function to a logarithmic function. So to do that, I have to take the log of this side to that base, right? So the log of x to the base 2 is equal to my exponent, which is log of 16 to the base 2. What does x have to equal if both sides are equal? 16. I like what you did. That's awesome. Okay? You want to know something? You know how I know it's 16? Because logarithm and exponential functions are inverses of each other. So basically what I'm saying is this. If I have 2 log x base 2, as long as those two are the same, they're inverses of each other. That is always my answer, whatever that value is right here. But you just proved a very simple way to show how that works. Okay? But anytime you see this, they're inverses. So therefore the answer is whatever x is. Okay? So far so good? Okay. Alright. I absolutely love this next part. I'm just going to shut the camera off and restart it here.